Welcome to this explainer. Today, we're diving into the profound, dynamic, and totally systemic physiological transformation that a woman's body goes through during pregnancy. I am so excited to unpack this for you today, because when you really look at the data, what the human body achieves over those 9 months is absolutely mind-blowing. Now, you might be wondering, sure, we all know pregnancy creates a new life, but what exactly does it do to the host, to the mother? Rather than viewing pregnancy as just a heavy physical burden or this generic, abstract concept, let's explore how these intense physical demands are actually a brilliant series of biochemical adaptations. To tackle this massive topic, we've broken it down into a 5-part systemic masterclass. We'll look at the ultimate systemic overhaul, how the body fuels the fetus, the hormonal command center, major organs going into overdrive, and finally, balancing immunity and risks. Let's get right into it. Starting off with Part 1, the ultimate systemic overhaul. Looking at the big picture, pregnancy causes all these wild, temporary, and sometimes permanent modifications across almost every system in the human body. And the ultimate goal for all of these biochemical changes is actually very simple: an optimal outcome for both the baby and the mother. That means those classic symptoms you hear about like nausea, profound fatigue, mood swings, or bloating, they aren't bugs in the system. They're the direct side effects of a body intentionally overhauling itself from the inside out to protect new life. Which brings us to Part 2, fueling the growing fetus. Let's see how the maternal factory meets these energetic demands. What's really fascinating here is how the maternal body basically runs a dual-engine energy system. On one hand, you have glycolysis, where the mother's body breaks down glucose for its own immediate cellular energy. But to make sure her blood sugar doesn't just completely crash, the body steps in and ingeniously upregulates gluconeogenesis. This is the synthesis of brand new glucose from non-carbohydrate precursors like amino acids and glycerol. It's a perfect balancing act, guaranteeing the growing fetus gets a steady, non-stop supply of glucose without starving the mother in the process. Now get this. With all this massive metabolic shifting and a 15 to 20% overall bump in the mother's metabolic rate, you'd probably think she needs to consume a mountain of extra food right from the start, right? Well, actually, the energy requirement doesn't really jump much at all during the first 2 trimesters. In fact, even in the 3rd trimester, it only goes up by about 200 extra kilocalories a day. That is just insanely efficient. So how exactly does the body account for that standard normal weight gain of roughly 11 to 16 kilograms? Well, surprisingly, only about 5 kilograms of that is the actual fetus, the placenta, and the amniotic fluids. The entire rest of that weight, that's all maternal stores of fat, protein, and a massive expansion of blood volume. To pull this off, the body's lipid metabolism totally shifts gears. It ramps up lipolysis, breaking down fats to feed the fetus fatty acids, while at the exact same time increasing lipogenesis to build up the mother's fat stores for later use. Let's transition over to Part 3, the hormonal command center, to see exactly who is directing all of this heavy metabolic traffic. It's the endocrine command centers. We're talking the hypothalamus, pituitary, thyroid, adrenal glands, and the ovaries. These glands act like the ultimate control room. Teaming up with the placenta, they seriously ramp up the production of essential steroid hormones. And these hormones are absolutely crucial for regulating uterine function, promoting placental development, and getting the breasts ready for lactation. This is literally a masterclass in biochemical engineering. Just look at these shifts. The pituitary gland actually physically enlarges just to churn out more prolactin. Meanwhile, LH and FSH levels completely drop off because estrogen and progesterone are running so high. Your thyroid-binding globulin increases, which raises T3 and T4 levels to handle that crazy metabolic demand we talked about. And my favorite example, the adrenal glands. They ramp up aldosterone, spiking it tenfold by the 3rd trimester. Why? Because aldosterone holds onto fluids, which is exactly how the body manages the massive increase in blood volume the mother requires. This perfectly sets up Part 4, major organs in overdrive. Let's see how this hormonal direction forces the body's major systems to work overtime. Take the cardiovascular system. It dramatically scales up to pump all that extra blood. By just the 8th week of gestation, cardiac output is already up by 20%, and it hits its absolute peak, a 40% increase, between weeks 20 and 28. But here's the wild part. Despite pumping way more blood, blood pressure actually drops below normal for the first 2 trimesters before stabilizing in the third. It effectively turns the heart into an incredibly efficient, multitasking powerhouse. And of course, to oxygenate that huge 40% increase in blood flow, the respiratory system has to step up too. The body manages this massive surge in oxygen demand by increasing the tidal volume by about 200 milliliters, alongside an increase in vital capacity and a drop in residual volume. Though it's worth noting, later in the pregnancy, as the growing uterus literally starts physically splinting the diaphragm, that tidal volume might drop back down just a little bit. Let's tie this all back to the physical symptoms women actually feel day to day. Ever wonder why nausea and constipation are so common early on? It's because the body deliberately slows down gastrointestinal motility to maximize nutrient absorption for the baby. Plus, as the stomach gets pushed upward, the esophageal sphincter loses some tone, leading straight to that nausea. On the renal side, smooth muscles relax and dilate to handle more capacity, but unfortunately that also brings a higher risk of UTIs. Every single symptom has a distinct biochemical origin story. Finally, we arrive at part 5. Balancing immunity and risks. This is where the body walks a delicate tightrope. The immune system performs this phenomenal high-wire act. It has to protect the mother while simultaneously not rejecting the fetus. So what does it do? It selectively dials down certain parts of adaptive immunity so it doesn't attack the baby. But at the exact same time, it actually exacerbates specific innate defenses. For example, a unique variant of natural killer cells, called uterine NK cells, concentrate in the uterus. They don't attack, though. Instead, they release protective cytokines and actively remodel arteries to protect the pregnancy. But as you can imagine, when these ultra-delicate systems get thrown off balance, complications can arise. A major one to understand here is preeclampsia toxemia, or PET. This is characterized by pregnancy-induced hypertension, significant protein spilling into the urine, and pathological edema, which is severe swelling. It is actually a major driver of acute kidney injury during pregnancy, and it happens to be the most common cause of severe hyponatremia. Maintaining an objective view on these risks, the shifting biochemistry is really striking. In a normal pregnancy, sodium levels naturally dip by about 3 to 5 millimoles per liter just from regular water retention. But PET can trigger a condition that mimics the syndrome of inappropriate antidiuretic hormone release, or SIADH. Basically, an excess of placental hormones can mimic a state where the body retains way too much water, overly diluting the mother's sodium levels. Data shows this is particularly more common in twin pregnancies or for older expecting mothers. Because of these wild baseline shifts, doctors literally have to throw out the standard rulebook when looking at a pregnant patient's lab results. Early in the first trimester, the glomerular filtration rate, the speed the kidneys filter blood, shoots up by an aggressive 50 to 60%. This rapid filtering causes standard markers like serum creatinine to plummet. So a serum creatinine level that looks perfectly normal for you or me, that could actually be a giant red flag for renal dysfunction in a pregnant woman. So, wrapping this all up, every single symptom, every shift in blood volume, every hormone spike, and every immune system tweak is part of a brilliantly orchestrated, dynamic balancing act. It is a completely temporary, yet totally systemic rebuilding of the human machine just to sustain 2 lives at once. Which really leaves you wondering, doesn't it? If the maternal body is capable of safely architecting this staggering level of systemic overhaul from scratch in a mere 9 months, what other hidden physiological superpowers are just waiting to be understood? It absolutely reframes how you look at human biology. Thank you so much for exploring this explainer with me today.